Welcome to another Mr. Paul video. Today we're continuing our coverage of 2.1, the integer exponents, but this time we're talking about Rule 2. In my opinion, Rule 2 is probably the most difficult to understand, but it's the most important, okay? And the reason is this. Rule 2 is called the negative exponent rule. And it's called that, obviously, because we're dealing with negative numbers as exponents. Remember for this exercise that a, b, m, and n are all numbers. So what this is basically saying is if I have a number with a negative exponent, or if I have a fraction, right, with the number and the negative exponent, I need a way to deal with it. Up until now, we've been dealing with positive exponents, and we can write them out. 5 to the third is 5 times 5 times 5, and we're okay with that. We don't have any way to deal with negative exponents until now. Now, let me start off by saying you might want to watch this video a couple of times because this one gets confusing. What this rule does is it allows us to take a negative exponent and rewrite it. Okay, let me be clear. Rewrite it as a positive exponent. You'll notice that I put the word or here. There are two different ways you could see negative exponents. One, if it looks like this, right? You have some number to some negative exponent. Or you have it in some fraction form with 1 on the top or some number on the top. And you rewrite it with and there's a negative exponent in the bottom. Now what this rule basically says is I can take this form here, a to the negative n, and I can rewrite it as 1 over that same a, the same a, but if you notice this n is positive, I can take this n and turn it positive if I rewrite it like this. Similar in a way, if I take this a to the negative n, I can rewrite this as a to the positive n. So let's see some examples, because examples are how we like to see math problems. Suppose I have 3 to the negative second power. I have something that looks like this. Okay? I have a negative exponent. I have to stop. I only have one rule for dealing with negative exponents, and that's the negative exponent rule. I have to deal with the negative exponent first. I have to rewrite it. Okay? If this was my problem, I have to rewrite this first. And that's what this allows me to do. I can rewrite this as not the negative exponent, but the positive exponent. So let's see, a to the negative n, a to the negative n. So I can rewrite this as 1 over a to the positive version of that n. Okay, our a's, right, are 3. The negative n is negative 2, but this time it's going to be a positive 2. So a to the negative n becomes 1 over 3, right? That's the same a. But I'm changing the sign of the n. 3 to the positive 2. I've now rewritten the problem. Okay? It's not to say that this is the solution, but it's now something that I can solve. Okay? It's something that I can solve. 1 over 3 squared, now that I've rewritten it, I can think of that as 1 over 3 times 3. 3 times 3. And I know what 3 times 3 is. That's equal to 1 over 9. The solution is 1 over 9, made possible by the rewrite, by this property. Okay, by this property. An example of this would be, let's just say I have 1 over 4 to the negative 3. 1 over 4 to the negative 3. I have something that looks like this. It's in a fraction form with a number and a negative exponent in the denominator. What this rule says I can do, what's the entire purpose, is to get rid of the negative exponent. I have to deal with this negative exponent first. I have no way to solve it until I do. This rewrite allows me to do that. According to this rule, it says I can take this negative exponent a to the negative n, 1 over negative n, 1 over a to the negative n, and write it as a to the positive n. So as complicated as this looks, I can rewrite it as a to the positive n. Okay, but I'm not going to write a, I accidentally did. I'm not going to write a because a is 4. And this is negative 3 is negative n, but now I get to change it to positive, so it's 4 to the third. Okay, this isn't the answer. This is only a rewrite, but I do know what 4 to the third is. 4 to the third. I can think of that as a normal exponent. That's 4 times 4 times 4. And 4 times 4 is 16. 16 times another 4 is 64. This is my solution. I was able to get to 64 because I was able to rewrite it first to get rid of the negative exponent. Before you end this video, let's do another example. Let's do another example of each of them. This one, we spent a lot of time in class. There's no rush in doing another example. Suppose we have something that looks like this, right? Some number to a negative exponent. This time we'll say 2 to the negative 5. 2 to the negative 5. The first thing that you see is the negative exponent, which means you need to pause. You need to say, okay, I need to rewrite it first. You have no way of solving it without it. I can choose this version or that version. If it looks like this left-hand side, then I rewrite it looking like the right-hand side over here. If it looks like the left-hand side over here, then I rewrite it as the right-hand side over here. Obviously, I put it over here, so it's going to be this side, this version. It's a number to a negative exponent, right? There's no fraction involved. So what it allows me to do is rewrite it without the negative exponent. 1 to the negative, a to the negative n. I can rewrite that as 1 over the a to the positive n. 1, this pen is awful. If it's okay with you, I'm going to use green again. Let me rewrite this. 2 to the negative 5 can be rewritten as 1 over a. Remember, a was 2. But this time I get to write this as a positive version. A positive 5. I got rid of the negative. That's the point. That's the entire point of using this rule. Okay, this is not the solution, but it does help me. 1 over 2 to the 5th. I know what 2 to the 5th is. I can think of that, right? This 2 to the 5th as 2 times 2 times 2 times 2 times 2. There's 5 2's, right? 2 to the 5th is 2 times 2 times 2 times 2 times 2. Okay, I can handle this. 1 over 2 times 2 is 4, right? There's 2's. 2 times 2 is 4. Times another 2 is 8. Times 2 is 16. Times 2 is 32. 1 over 32 is the solution. 1 over 32 is the solution. Let's do another example of the fraction kind. Suppose we have 1 over 5 to the negative 2. 5 to the negative 2. It looks just like this. 1 over some number to a negative exponent. 1 over some number to a negative exponent. What this rule says is I can rewrite this as that same a, which is 5, to the positive version of that exponent, right? So the positive version of this is positive 2. Okay? This is only rewriting it. It does not solve it. My issue is my solution is not found yet. but it gave me a good step in the right direction. 5 squared, after the rewrite, is something I can solve. I know that this is equal to 5 times 5. And I know 5 times 5 is equal to 25. This is my solution, made possible by using the negative exponent property, the negative exponent rule. Okay? It's only one rule, but there's 2 different ways that you can use it. Watch this video one more time. I highly encourage you to do so if you're still confused. That's all for today's video. Peace.